Today we are going to discuss the relation between electric field and potential. This relation is unique because electric field is a vector quantity whereas potential is a scalar quantity. And we are going to attempt to obtain a relation between these two quantities. For this we draw two equipotential surfaces A and B which are separated by a distance dr. The equipotential surface A has a potential V while the other surface B has a potential V plus dV. This dV, the increment, may be positive or negative, that we don't know for the moment. The direction of electric field is shown and it is 90 degrees to the equipotential surface, to both the equipotential surface. And dr is the path or the shortest path to reach B from A, from this point. So basically dr is the perpendicular distance, since shortest path will be perpendicular distance. Let us see what is the definition of potential difference. So for this, we take a small charge q and move it from A to B. Then from the definition of potential difference we can write. We imagine a small charge q that will be moved from A to B. And how will the movement? The movement will be in such a way that at each and every moment, the electrostatic force is equal and opposite to the external force. That you already know. So potential difference between the 2 points A and B, or VB minus VA, is work done by external agent per unit charge, that we know. You are moving the charge from, this is important, A to B. So this is your path. Remember. Hence potential of V minus A, VB minus VA, is work done by the external agent per unit charge to move from A to B. The amount of work done by the external agent to move the charge from A to B is per unit charge is VB minus VA. This can also be rewritten in terms of electrostatic force. How we rewrite this? Just by introducing a minus sign. Because we know that work done by external agent is equal to minus of the work done by conservative force, and electrostatic force is a conservative force. So everything will remain same, but the nature of the force will change from external agent force to electrostatic force, and a minus sign will be introduced. So this is the preliminary setup that we need to obtain the relation between field and potential. Let's see. Okay. Next, potential at point B. If you remember the diagram, it is V plus dV minus potential at point A. Sorry, this should be V. This should be V. Potential at point V. Potential at points surface A is V. So we have V plus dV minus V. Okay. Now minus of the work done by electrostatic force. For a unit positive charge, the electrostatic force does some work, and that work is given by E dot dr. Actually, work done is given by F dot dr, but F is equal to Q into E. In case of per unit charge, what happens? You have to divide this force by Q. So Q will get cancelled with Q, and you will be left with the work done formula as E dot dr. This is for per unit charge, remember. So now, on subtraction, we get dV. E dot dr is magnitude of E, magnitude of dr, and from the path, if you are moving from A to B, then angle will be 0 degree. So we get magnitude of E is equal to minus of dB by magnitude of dr. Okay, so E is in magnitude, dr is in magnitude, but dV is not in magnitude till now. So left hand side of this equation represents magnitude of E. So right hand side is, it is better to keep it in magnitude. Right hand side, the denominator is in magnitude, no problem, but the numerator is not in magnitude. So what we will do, we will convert this into magnitude. The right hand side dV can be written as minus of magnitude of dB. Now why I have given minus here? See, dV must be negative because potential decreases in the direction of electric field. Whenever you move in the direction of electric field, then the difference in potential, final minus initial, must be negative. To understand this, imagine, okay, to understand this, suppose this is the direction of electric field. Suppose this is Q charge plus Q charge. Then this is the direction of electric field. Potential at this point A and potential at this point B. This is suppose R1. This distance is suppose R2. So we know that from the diagram it is clear that R2 is greater than R1. If this is the case, then what will happen? Potential at A will be greater than potential at B. Okay, therefore BB minus BA is negative. Is negative. So whenever you are moving in the direction of electric field, be it for positive or negative charge, both case, if you are moving in the direction of electric field and you find the difference of potential between these 2 points, VB minus VI, final minus initial. Under that situation, the potential difference has to be negative. Okay, because VB is smaller than VA. So whenever you move in the direction of electric field, remember potential always decreases. So let us complete the derivation here. So dV must be negative because potential decreases in the direction of electric field. So since dB must be negative, dV can be rewritten as minus of magnitude of dV, since it will always have minus sign. So put it here, minus minus becomes plus. So magnitude of E is equal to magnitude of dV by magnitude of dr. So this is basically a magnitude relation, E equal to dV by dr. So when we write E equal to minus dV by dr, you have to remember here that E and dr are in magnitude already, but dV is negative. So ultimately E is equal to plus dV by dr if you want to find the magnitude. My advice to you is that if you are solving numericals, then solve it by taking magnitudes only. So this formula is better if you use to solve numericals. And to find the direction of electric field, you can use this line. To find the direction of electric field, just use this line. How will you use this line? That means the direction in which potential is decreasing. That is the direction of electric field. Simple. The direction in which potential is decreasing, the fastest actually, the direction in which potential is decreasing the steepest, that direction is the direction of electric field. I hope you have understood a little bit about the relation between electric field and electric potential. Thank you.